Hi everyone, this is Miss Ward. Tonight we're going to be going over Concept 7 of the Earth's Formation Unit. Just so you know, this section is going to focus on the inner planets, and we're going to kind of get into a pretty detailed look at what is really going on in them. So, we have to first define our solar system before we can start talking about the inner workings of it. Recently, there have been pretty strict guidelines that have been put in place that define what criteria something needs to be considered a planet. A planet's definition is that it must orbit the sun, it must be round in shape, and it must have cleared out its own orbit. These three rules are what they used to exclude Pluto from being a planet. Pluto meets the first two, but does not meet the third. The problem was that we found several more objects in addition to Pluto that were very similar in size and shape that had other objects around them. They were not able to clear their own little area out. They were not able to carve their own little niche in the solar system, but they were still in the solar system. So the question became, do we include all of these other planets or do we exclude Pluto? It was easier to exclude Pluto, so they came up with these rules and defined the fact that you must have cleared out your own orbit in order to be a planet. So this is the order of our solar system. We have the Sun, then you have the terrestrial planets, which are Mercury, Venus, Earth, and Mars. Then there's the asteroid belt, which separates the terrestrial planets from the Jovian planets. The Jovian planets are Jupiter, Saturn, Uranus, and Neptune. Beyond Neptune, we have the Kuiper belt and then the Oort cloud. The Oort cloud is what separates the solar system from the rest of the universe. It's important that you know this order, and you will be expected to memorize and know this order. So our terrestrial planets are Mercury, Venus, Earth, and Mars. They are all primarily made out of silicate rocks or metals. They also have solid planetary surfaces. Essentially, they're the hard planets that are made up of matter that you could physically stand on if you were there. This is a picture of Mercury. Mercury is the closest to the Sun, and it orbits the Sun every 88 days. It rotates on its axis once every 59 days. It is highly cratered and has little to no atmosphere. This causes huge temperature fluxes from 427 degrees Celsius to 173 degrees Celsius. Something important to note, when we say that it takes 88 days for it to go around the Sun, we define that as 88 Earth days, and it rotates on its axis every 59 Earth days. If you lived on Mercury, it would feel like it took 59 Earth days for the Sun to rise and set. And it would feel like it took 88 Earth days for it to go around. So there's only about less than 1.5 days to every year in Mercury defined how we defined our Earth days and years. Here's a picture of Venus. Venus has an orbital period of 225 days, and it rotates on its axis every 243 days. An orbital period is the same as saying it takes 225 days to revolve around. That revolution and orbital period are interchangeable vocabulary. This means, though, that a day on Venus is longer than a year. It actually goes around the Sun faster than it turns on its own axis. Venus's atmospheric pressure is 90 times that of Earth, and it is made out of 96% of carbon dioxide. Venus is the brightest object in the sky, apart from the Sun and the Moon. So generally speaking, if you're going to see a planet from Earth, many times it is Venus. Here's a picture of a planet we should all know very well. So Earth's unique atmosphere and distance from the Sun allows water to exist in a liquid state. Earth is the only known planet to have oceans of liquid water. There have been ice found on other planets, but not liquid water. Earth is the only known planet that has proper combination of water, temperature, and oxygen to support life. Here is our picture of the red planet, Mars. So Mars is about 50% further from the sun than Earth is, so it's much further out than we traditionally think of it. Its orbital period is 687 days, which means it takes that many days to go around the sun once. And then it rotates on its axis once every 24 hours and 37 minutes. So a day is pretty close to that on Earth, but a year is almost twice as long. There are many volcanoes on Mars. The pressure and temperature of Mars' atmosphere are too low for water to exist as liquid on the surface. But several NASA spacecrafts have found evidence that liquid water did once occur in the past. Here's a picture showing you where the asteroid belt resides, as well as the inner planets. You can see the sun is in the middle. Moving out, you've got Mercury, Venus, Earth, and Mars. And then there is an area that separates Mars and Jupiter, and that is the asteroid belt. Scattered in orbit around the sun are bits and pieces of rock left from the formation of the solar system. Most of these objects orbit between Mars and Jupiter in a grouping called the main asteroid belt. They orbit there because of Jupiter being so large. It has a large gravitational pull, and so this is where those objects have settled. The region contains the dwarf planet Ceres, which is a quarter of the size of the Moon. The force of Jupiter's gravity is thought to be the reason for the belt, as I just explained. Okay, that's where we're going to leave it for tonight. Your next set of notes will go into the outer planets, but this is a long set of notes, a lot of information, so I want to make sure I cut you off. Make sure you fill in that WISC. Bring any questions you have to class with you. Have a great night.